we are hardware and software engineers, and we are seeing energy, let's to say, from side of some small devices, battery powered devices, and so on and so on. This is one aspect of smart energy that is important, but not crucial one. And we couldn't attract, let's to say, big companies for some small money to apply for the projects on energy efficiency and so on. And also smart transportation. We didn't have too much applications from smart transportation. It is also very important, an important field. And for smart everything or anything everywhere, also we didn't have, as to say, much applications. And in the future course, we expect, let's to say, applications from this field. Like example, I see here many people from field of economics, from field of accounting, from field of tourism, from field of some services. And all those fields are interesting to be classified like smart anything everywhere. And me, like, let's to say, member of some evaluation committee for our project, we invite the people to, let's to say, to apply with some let's to say, interesting ideas outside of those classical topics related for electrical, mechanical, architectural engineering, and so on. Let's to think a bit in sustainable development, in other fields, and let's to collect ideas from other fields. Always when I come in Novi Sad, I see a lot of people in Novi Sad. They are really innovative people. Always I'm going in some other hotel and see that owner of the hotel implemented some services. I'm asking them, why you implemented these services, like owner of some hotel in some small city and so on. I like it. No other cases around region that someone is applying something that likes. In Novi Sad, a bit in Slovenia, and others regions. Then I see, let's to say, 1,000 ideas in this smart anything everywhere, and let's to start from this. If you collected ideas, then you collected during your active period about 1,000 ideas. I always forgot to write some idea and then forgot this idea naturally. Then let's to apply or with smart education, also modern topic, smart medical education, smart, we heard about smart psychology, and smart other fields. Because even someone that is giving lessons by Skype or Viber could be innovative, could be smart projects. And also those some smart tricks in some other fields can bring more benefits than this smartness in smart home. Because now too much systems of smart home, and one smart home system costs about 10 euros. And half of region are doing smart home systems. And I see this, Zoran, because I spoke with our colleague that is coming from biochemistry, from field of biochemistry, from field and so on, and there is no too much analog knowledge. People to know something out of digital. They are mainly digitally based and digitally oriented. And then let's to see some topic, some smart ideas. Will be good of you to hear today. Have you any smart ideas out of those that we heard today about smart agriculture, smart health, smart education, smart transportation, smart etc. That's some, let's to say, some my triggering the system about let's to think in some other areas, because there is a rule for 20% of the efforts, you will bring 80% of the gain. Never with 80% of the efforts, you will not gain this 80% of the gain. That is one of rule. And I always earned my money with small efforts and doing the best efforts at faculty, university, education, and so on, and earning less money. That means that should be innovative in this area. It is some. Okay, thank you.
Okay, thank you, Radovan. Thank you. Now I would call Mr. Darko Stanimirović to share with us his thoughts about digitized anything.
Hello, everyone. Can you hear me? Yeah. Okay. My name is Darko Stanimirović, and I represent a company Zumoko, which specializes in augmented reality and virtual reality solutions. So in the last 7 years, since we are working in this field and since the company exists, we worked basically in various verticals. So I don't know if you know much about augmented reality and virtual reality. Essentially, there is a small distinction. So augmented reality is basically a technology that enables us to add digital content to the real world around us. In virtual reality, we immerse a user into a completely new virtual environment. Usually, we use hardware such as augmented reality glasses, for instance, Microsoft HoloLens, HoloLens 1, HoloLens 2, and virtual reality glasses, Oculus Quest, let's say, and so on. So essentially, what we do, we develop software. This software can be used, as I said, in various verticals. In Serbia, mostly we worked in cultural field, so working with the galleries in digitization of cultural heritage. And also we developed a couple of educational projects. For instance, mobile application with augmented reality that teaches children about traffic safety. So perhaps you know about it. It is called Pažljivko. Abroad, we developed also a different products for different verticals, such as marketing. For instance, we developed a platform that enables, let's say, cosmetics brands to add augmented reality marketing campaigns directly on the packaging. So, for instance, if you have a QR code, let's say, on a packaging of a certain cosmetics product, it is possible to craft a marketing campaign that is going to be, let's say, crafted specifically for a certain region or for a certain set of individuals. So something similar that Facebook and Google are doing. So basically they enable marketeers to target specifically a certain group. Augmented reality bridges this gap between, or can bridge the gap between digital and the physical. So when you take a physical product in your hand, you can already start interacting with it through your mobile phone using the QR codes, or let's say the NFC chips, or just by scanning the packaging, so using the image recognition. So this is one instance of, let's say, adding additional layer of digital content on the physical world. What is also interesting topic for augmented reality and virtual reality is the worker education. So for instance, we have a long project in Netherlands where we are developing health and safety education modules for construction industry workers. So in Netherlands, like in every country, there is a huge shortage of construction industry workers. So usually people from Eastern Europe come to work at construction sites in Netherlands. The problem here is that most of them don't have a proper health and safety education, how to properly behave and safely work at a construction site. So we developed a virtual reality, let's say, learning module that covers basics of health and safety on a construction site, and also added translation in different Eastern European languages. And this combination of augmented reality and localization to a worker's language enables this software to achieve, let's say, enables users to achieve much higher retention of the knowledge than using, let's say, traditional methods, PowerPoint presentations, books, and so on and so on. This is one strong feature of virtual reality-based learning, and it has a big future, in my opinion, especially for worker education and worker re-education. For instance, in Netherlands and also in many other countries, also in Serbia, there is a big group or a large chunk of workforce that is not properly trained for jobs that exist now. So basically, there are some workers that worked in the fields that are completely automated now. And essentially, they have additional, let's say, 15, 20 years until the retirement, and they cannot find proper jobs in, let's say, a digitized age. This is what virtual reality or with virtual reality-based learning can enable or can help people to quickly gain new specific skills. So for instance, this is also connected with transition to renewable energy. Right now, let's say in Netherlands or in Western Europe, there is a huge demand for workers that are capable to install, let's say, thermal pumps, heat pumps. It depends how it's called in different regions, solar panels, and so on and so on. So the idea is to help transition workers that were working previously in the fields that are not employing that many people anymore, and teach them these new skills so that they can help also in this energy transition. So that's it.
Thank you very much. Thank you. I remember some 10 years ago, my colleague at the company in Czech Republic, and he made a digital mirror for boutiques. He took one smart TV set, and this was very interesting, and this was like start of digitizing anything. Then he projected this screen, someone who is in the boutique, and you could change colors of your suit, or to share with your friends on Facebook, on everything, to put the voting for the best color or best model, and you don't need to go to change everything just to stand in front of the mirror. So this is nice. I'll call now Mr. Miloš Stanković to share with us some business aspects of this topic.
Hello, everyone. My name is Miloš Stanković. I'm a founder of company Pyron Technology, which is a boutique consultancy firm, mainly focused on digital transformation of the companies, of the businesses, and also on implementation of Industry 4 technologies. Industry 4, I believe you're aware, is a fourth industrial revolution, which is currently happening in the world. It's a new trend. It's actually not a new trend, it's 10-year-old trend, based on the technologies that emerged, that are now allowing us to capture, analyze, learn something from the data, and incorporate into our daily lives. Basically, it's a digitalization of our lives in every manner, in industry or businesses. So these technologies are, I believe, not so quite new in Serbia or in this region, but are on a low level of implementation or acceptance. So there was definitely a need for consultancy to understand, to guide the businesses on how to proceed with this. Usually when people talk about digitization and digitalization, I believe you understand the difference, what it is. Digitization is just making something digital, like scanning a paper and you get a digital form of it. So that's a digitization. But digitalization is more focused on what you're going to do with those digital assets. So it's more on process side. So understanding this and how you can utilize this knowledge that you have in business, digitalizing the processes and the way people work is how we see digitalizing everything. The way businesses work today is mainly on a low level, using, for example, Excel, Word, etc. I'm talking about services and even some manufacturing companies. They're still on this level. Scheduling is quite primitive, still using Excel or some other forms. Where moving to a digital age or moving to a next digital level, these tools are becoming obsolete. Basically, they are out of the way. People are not using Excel sheet to register, to track or monitor something. Everything is done in a more comprehensive way. Data is most likely input from one side to the platform. There are several connections, let's say, several departments that see this data in their own structured way they need it. For example, finance, or it's logistics or whatever. So all the data is transparent, all data is there, but how it's presented to different sets of users is different, of course. So to be able to move to that stage and understand and have this synchronous working of the business, it's very important to know what's your current state, how digital you are nowadays. So mostly when I'm speaking with CEOs and managers, it's not related only to Serbia. It's a region, it's all around the globe. Everyone are saying, we have Excel, we have Skype, WhatsApp, whatever, we are digitized. Of course, you're most likely digitized just because you're sending data from one to another way in a digital way. It doesn't mean that your business is digital, that it's digitalized. So first of all, we need to do a proper assessment of the business, of holistic view of the business, and understand how you are operating at this now, better say now, and then see the analysis, do the analysis to see how you can actually move forward. What's the next steps? What are the next projects, initiatives that you need to take in your business to move to the next level of digitalization? Many projects that we've seen today are related to developing some hardware sides, something more on hardware side. Yet digitalizing everything, or talking about business more on business side, is digitalizing the data, the knowledge, the idea capturing, as you mentioned also. So to capture the idea, how you will work with that idea, how you will develop idea. So something more on a soft side, not on a hardware side, and to be able to grow, to optimize the processes, to optimize the way of the company is working. It has to be laid out on a table with all the processes mapped, with the tools mapped which are used, and then put all the data to one single center, to the single source of truth, let's call it that way, where everything is collected and from where everything is distributed. So we all know the same information, we work on the same level. There shouldn't be that a worker in a manufacturing facility has some knowledge. He is the only one who has that knowledge, how to operate a certain machine, or there is some special way of pushing the buttons, and no one else doesn't know that. That information is also captured in a platform, or in a, let's say, that single source of truth. Everything is shared, and basically to reach that level, to get this overhaul or overall view of the company, a digital maturity assessment is needed. That's what we do. That's how we actually enter the digitalization of everything. Technologies that are going to be implemented are just tools. They're there to help people, but they're not the one that will do the business for you. So in order to work, to make the business profitable, of course, that's the reason of every company that exists. You need to have people aligned, how they work. So that's what Darko also mentioned, to train them, to educate them on the right level. You need to have the processes optimized, understood properly by everyone, and then the technology come by itself, just how to put this all together. So yeah.
Okay, thank you, Miloš. I would like to start discussion. Is there anyone who wants to share this? Yes, please. Just wait for the microphone.
I mean, I understand. So basically, you're asking about can we estimate if, let's say, a certain video material is truthful or a certain audio material is truthful. I mean, this is not per se virtual reality. It is more related to, let's say, deep neural networks. So as you probably know, now exist deep neural networks where you can feed images of a person or videos of a person talking, and then you can just enter the script and plug in the actor on the other side that is actually doing the gestures, and then it matches, it replaces the actor with the person that for which the network was trained. Probably you have seen they did this with former US President Obama and some fame Trump and some other famous people. But this is not related directly to our work. But yes, I mean, with deep neural networks, it is currently possible to completely fake audio and video, especially, let's say, of a person talking, saying something. So yeah, this is correct. I mean, with the current level of technology. Yeah, there are detectors. Yeah, there are certain detectors, let's say, but as I say, this is not exactly my field, so I'm not sure how far are the detectors, how easy it is to detect if something is a deep fake or not. But I wanted also to comment, if that is satisfactory. I wanted also to comment on what has Miloš mentioned on digitalization of a process. We did an interesting project. I think you might like it, how we developed it. So we worked with Fujitsu Labs of America. They have a factory in Texas where they develop industrial routers. So essentially, it's a similar technology to a router that we have in our home for Wi-Fi, but these routers are, let's say, custom made. So each router has comes with a specification. So each order comes with a specification, what components should be installed in this router. So you can imagine this router is like a grid about this big. And then in this grid, you can plug different components at different positions. So Fujitsu, being Japanese company, had really nice way of, let's say, ordering all the components, adding numbers to them, different codes and so on and so on, to make it as easy as possible for a worker not to make a mistake. But still mistakes were happening, because if you just change a position of a certain component, plug it into a different, in a wrong slot, and then you ship this router and it goes around the world, basically the company is losing money, because once it comes to the location, if it's not working properly, then it comes back and so on and so on. So they wanted to build a system with HoloLens, where basically with augmented reality glasses, we are able to recognize where this router is exactly in a physical space with regard to the user. And then we created a system where the orders in the factory are coming, let's say, to a certain database for all these so with the specifications for each and every router that's being produced. And then when a worker starts, let's say, his shift, he gets a set of jobs that he needs to, let's say, a set of routers that he needs to assemble during his shift. He scans it with a QR code scanner. This QR code scanner is connected to the factory, let's say, system, which also holds all the specifications and so on and so on. And then the system feeds the three-dimensional data directly to the user, and he sees it on the smart glasses. So what happens? A user scans. First, which router is he building? The next thing that he scans, he takes any part from the box, scans it, and then the glasses show exactly in three-dimensional space where a certain slot, a certain part should be installed in which slot. So I forgot the numbers because it was a couple of years ago, but I think what we gained acceleration of around overall in the overall process of around 30–40%. So it took them 30–40% less time to assemble one router for each worker. We reduced the number of errors to 0. Basically, since they installed this system, not a single worker made a single mistake, because basically it's not possible. What you see in front of your eyes is always exact position where you should install something on this router. You don't need to look at the paper. You don't need to waste time by looking, oh, where should I put this and that? So basically, the paper became completely obsolete in this process. The whole process of manufacturing these routers became completely digital. So this is one interesting and I think a good use case when we talk about general digitalization of processes.
Maybe I can add on top of that. It's a great use case. So basically, they reduce the time to manufacture something by 30%. That means they have a certain number of these to be assembled more on the same shift. Basically, they increase their productivity. Productivity means increasing the profit for the same amount of time. But what is, just to put it on the next level, so every time a worker scans or 100 workers scans what they're currently working on, somebody on a next level, managerial level, sees exactly how much of these products are in work, how much they're finished, who is late, who is above or faster, whatever. So they can start planning their deliveries to be exactly on time when they need it. So if they know that 1 or 2 workers are quite slow and they have 5 workers that are faster, they still know they're okay, we will be good on time, we will manage everything on time. But if they see that everyone are slow because, I don't know, something happened, they know exactly how to reschedule their deliveries, and immediately the clients are notified that there will be a delay. The C-level, the high level of the company also know exactly when they can expect money for this, because usually when they ship or when it's delivered, the money is on accounting side is recognized. Basically, that's what C-level only cares on. So basically, they just want to see money. So all these small steps when the person scans up to the most the top level, everything is governed by from the one single source of information and data collection and analysis. So yeah.
Yes, interesting thoughts. I recall now one software in architecture and civil engineering, which I saw several years ago, which was like breakthrough in this area. So, you know, in former times, architects made some plans on paper, and after that made some models with several cuts to show their main idea. But those people made a software which on 2 screens shows how the building is growing from scratch to the finished size, and at the other side you have bill of materials or the need in manpower, in how many trucks of concrete and everything you need at any part of the system. And this was interactive software. So if you say, what if I remove this wall or rearrange the flat, they can online change this, and the bill of material immediately goes tracks these changes. So it was fantastic, and it was like breakthrough in contracting the job in building system, because everyone who looks at this building has a real-time simulation of course augmented reality is augmented real time. So fast, and you can see in 10 minutes how this building will be, and at every part of the projecting process, you can see how many resources you need for this. So this is one of the examples of very good connection between software technology and the other part. Mainly
exactly.
in this field of digitized anything, we do not work, we as electrical engineering or software engineers, we do not work with people like us. We work with people from other professions, and we try to enhance and to help them to have better throughput or to have less less money spent for delays or for some errors in process. So this is a good one.
Yeah, what you mentioned is actually it's called product lifecycle management, where you actually have a design of the product, which you can simulate. You can understand how it's operating, basically creating a digital twin of that, and change it the way you want it, and then you can make different configurations, like what you mentioned, just remove a wall. For example, if you have a car, maybe it's a car for UK market, so basically you just have everything mirrored. So it's a different configuration, but it's basically the same design of the car. So all these are handled by product lifecycle management platforms, which are dealing with the 3D, with information on electrical side, on electronics, on basically every information that you have on a product as it should be made is in there. So, and if you have a feedback loop from if you produce a product and you make it smart, let's say it's smart, so digitize the information that are coming from that product, you put sensors, you put that loop back to the simulation side or to the product lifecycle management platform. You know exactly how your product in real life is operating compared to the digital one. That's a perfect example of digital twin, and understanding how your design is good or bad. You can improve it based on exactly on a field test that is happening. So every next iteration is better and better and better. You don't have to learn the hard way. You can just have one test, and then on that test you implement a lot of new design changes, and the final product might be completely different from what you started with. But still, it's something that a system is a digital system is teaching you how to develop the product in a smart way.
We had several discussions, but it were all done from our side. So I'd really like to see if there is someone who would like to join us, either from this audience or from online participants. So I call you all to join us and to please. No.
Thank you. I was just going to ask your opinion on some, let's say, societal issues related to digitalization. We understand that people accept digitalization at different levels, and digitalization actually needs to be participative in order to be successful. So my question would be, what is going to happen with the underrepresented groups of the society who cannot keep up with the pace? And is that maybe going to be a different societal problem as well? Or what do you actually think about that?
So yeah, you're quite true. It's true that there are a lot of social part of this that people don't understand, or they perceive it as something, digitalization is something mystical, not so easy to understand, whatever. But the thing is that different generations perceive digitalization in different ways. For example, my kids, they're quite easy to work on a phone, on a smartphone, and for them it's easy. For my parents, it's quite hard to bridge this gap. And there's definitely a need to do the education, but not education in any negative way. Of course, it's bringing the technology to each generation on their own pace, in a way they need it and when they need it. So we saw the presentation for I don't remember who was taking it, but it was about for elderly people to understand and have the technology that will help them to find stuff or monitor their health. So digitalization is something that not each of us will accept it so easily to change our lives like this. So it has to be progressively introduced into our lives. That's the way I see it. But elderly people, definitely they lived in a world even without digital. So for them, radio and TV were the most digital technologies at one moment. Nowadays, we have more and more connectivity between each other. Phones are even exchanging files when we are close. Sometimes it's quite hard for them to understand how this works. But social part of it is that definitely an education or a proper introduction of these technologies is needed, definitely. And maybe augmented reality is something, even though it sounds quite high tech, it's actually something that is helping a lot of people to do this. So I believe I responded. Correct.
Yeah, thank you. I was just thinking about the forms in which we present the options for people educating themselves enough, and how available the resources are. For example, if you speak about our country, like what is going to be expected in next 10 or 20 years, and are we going to have any problems regarding digitalization in terms of available to everybody, related to knowledge and the usage and all sorts of other resources?
Yeah, that's a good question. I mean, it's a process. It's something that takes time. We cannot expect from people that in a week or in a year are completely educated on everything, but still it's a process that we need to go through. And I believe we are on a good way. We are doing this, but it's also on a personal level. How reluctant are people to accept this? How do they want to do anything with it, with the technology? So I have few friends that have the very old Nokia's mobile phones. They don't want to move with the technology, and that's okay. But you have also quite old people that are very keen on using the latest technology. So basically, it's also on a personal level how you want to do it. Yeah.
Thank you for this question. It's a very interesting topic, and it is something that is it really goes as Miloš mentioned. So it is important from a personal level to the top level, or let's say societal level. We as companies working in digitalization. So mostly we work with stakeholders who are business owners. So what we provide to them, we provide them value. So everything that we do mostly arises from a business perspective. So increasing productivity, making money, and so on and so on. this is how business world works. On the other hand, there are also governmental programs, as I mentioned, in Netherlands, where we are part of, where the government is funding initiatives to help, especially elderly people and people that are not so knowledgeable about technology, but to help them use new technology to learn new skills. So it's not necessarily making them completely educated about digitization or digitalization. We use these tools that are available to us to help them learn new skills. And this is really something that is working. So for instance, in our field, in let's say augmented reality, virtual reality, user is not even dealing with a keyboard or a mouse, nothing. So he's presented three-dimensional content. Let's say if you want somebody to learn how to operate a certain machine, he sees this machine virtually in front of him. He sees a virtual avatar or a virtual 3D model that explains him how to operate a certain machine or how to install a certain machine or how to maintain it. So the technology, let's say, is not always an enemy of older people. It can be a friend of people who are, let's say, not so technologically advanced, but still are capable of learning and working, and we can help them basically learn new skills with augmented reality and virtual reality. But at the level of the society, there needs to be an initiative that is at least partially funded by the government, where we will help, let's say, older workforce learn new skills. So this could be something that, or let's say in many countries, it is the case. I know there are also some initiatives in Serbia where people can gain new skills in IT, let's say, for free. Again, it needs to be crafted to a different knowledge levels, because usually when they develop such modules or such courses, it's all at the same level, but not all the people coming are at the same level of knowledge. So it has to be, let's say, some very basic level, then a little bit more advanced, and so on and so on. Then again, it is about the money. It is about organization. Somebody needs to create, let's say, there are many European Union projects that are available for funding such initiatives. But really, this is something that requires work. You know, every project like this one requires a lot of work, a lot of preparation in order to get the funding and get the things going. So there is a way. It is not true that it is not possible. Everything is possible. It is just that requires certain organization and will. I know. So.
Yes, thank you. Any more questions from the audience?
Then if I can continue.
Oh, of course, please do.
That was an interesting topic that you mentioned in the construction industry, or let's say in architecture and usage of new technology in architecture. So I guess you heard about Leica. So it's a company that produces all kinds of different sensors, laser scanners, and so on and so on. So Leica has very advanced augmented reality systems that integrate directly with building information models. So in construction industry now, everything is about BIM, or building information model. So all the data regarding the, let's say, the initial designs, architectural designs, construction plans, and so on, all the plans for the installations are included in one enclosed information system. So what they do, they have a field scanners that you can take to the building site that is already, let's say, construction site that is already So let's say at the circular level of completion, 20%, or it doesn't matter. And then you can directly overlay the, let's say, digital twin in this case, or the digital design against the real site. Why is it helpful? It is helpful first for the engineers, for construction engineers, to assure that everything is built according to the plan, because you know these errors that happen at construction sites when somebody is not built according to the plan are extremely expensive. Then also for the workers and for the managers on the site, it helps them basically remove any uncertainties about how something should be installed and also and built, and helps let's say for a better planning. So at each stage of the building, you can double check and see if it's directly match with what is planned. So
yeah, I can maybe add on that. You gave a good idea on 3D scanning. So 3D scanning is a process of scanning. Sorry, no, it's my phone. Of scanning a physical model and creating a 3D model of it, or a mesh or whatever, which can be used, for example, in when you manufacture a product or part. You can scan it very quickly, and you can immediately correlate each other and understand how good the manufactured part is or bad. And you have on the shop floor, you have the decision, should this or quality control on the shop floor. So is this part good or bad? And immediately discharge it from the further manufacturing. I know a very good example in Spain, in I think it's SEAT company, which is producing the cars. They have they're connecting the dashboard, complete dashboard of the car, and the complete dashboard is on a scanned on a trail, and in 10 seconds the quality engineers, they know exactly if the dashboard is properly assembled, the tolerances are correct, there are no deviations, there's nothing, and you literally have a go no go place on a track where the dashboard is just removed or just go for the assembly to the car. So basically in 10 seconds you have all the information you need to know should we install this or not. This also goes into reporting, so basically they know how good their manufacturing is. So if you have from 1,000 dashboards and you have 100 bad, that means 10% is bad. That's in production, that's very bad result. So they have to change some things. Also, every dashboard is money, basically. It costs some money. If it's bad, that's scrap, or if it needs to be reworked again, it's something that costs money. So that affects also on a business side, and the managers, they know exactly how good or bad they are in creating money and creating value. So yeah.
Thank you. Thank you. Any more comments or discussions, questions? If not, we can conclude this session. Now, because we have some parallel sessions, we have a short break, and we'll be back at the plenary session at 4:45. So I asked our online visitors or participants to come back at 4:45, and then the others from the other rooms will join us. So we'll have this link, the plenary session, which will conclude our first day. So until 4:45, goodbye.
Thank you. Bye.